I'm Sarah Jensen, editor of OEM Off Highway, and welcome to Design and Engineering Insights. Today, I'll be talking with Samuel Reeves, CEO and founder of FORT Robotics, about some of the trends the company is seeing in regards to automation of heavy-duty equipment. So thank you for joining me today.
Thank you. My pleasure. Thanks for having us on.
Yeah, definitely. So maybe just to start, if you could talk about some of the current trends you guys are seeing regarding the implementation of automation and heavy duty equipment. Are there specific ways you're seeing automation be implemented or types of equipment on which it's more common than others?
Yeah, absolutely. Well, I mean, I think this topic is really exciting. I mean, obviously we're a robotics company, so we've drank the Kool-Aid and we were really excited about robots before it was cool. But it's a really exciting time to be talking about automation in the off-highway vehicle world, because it's kind of like the world has hit this perfect storm of factors that have made automation go from kind of science experiment to like, oh my God, we have to have this for the future of the world. And so that perfect storm, it all feeds from the macro factors that we've all been hearing about. So, there are huge labor shortages across agriculture and construction, a little bit less in mining. But this has gotten to a fever pitch over the past couple of years. And there are companies that are saying, we could make more money, we could ship more product, we could do more if we had more people. And so especially in developed economies, this is something that is really a challenge to growth. So the labor shortage is one thing. Work is actually really unsafe already. So there's like 4.6 million injuries in the workplace in America every year. And this costs employers around $171 billion every single year. And so before the labor shortages even happened, work was really unsafe. So that leads us to say there's a huge opportunity to make that better. And then the third factor is that the tech is finally here. So McKinsey's estimated that about a third of jobs can be automated today, physical jobs, physical labor can be automated today with the technology that we already have. And so finally, the tech has arrived. So when you take the inherent safety problems with work, combined with the labor shortages, combined with the tech finally arriving, you get this perfect storm that says automation's finally here. And so what we're seeing is every OEM has realized this. It's gone from kind of like, well, maybe we'll have a little skunkworks thing, or maybe we'll fund some research at Carnegie Mellon, or maybe we'll just kind of dip our toe in the water to, we have to be involved in this trend. And so that's been an interesting change to see wholesale, like even the most conservative companies jump into automation kind of like 2 feet forward. Mm-hmm. And I think, there are varying approaches, but some things that we would say is like, it's a broad trend that's going to apply across every machine. And so, it kind of depends on where you are as a company as to how you're approaching it. Some companies have, small skunkworks groups that are really focused on, making Machine X autonomous. And then once they get that right, they're going to flow it out to the rest of the product lines. Other companies are embedding, their autonomous vision into their business units, and everybody that works on every machine is infusing some kind of automation into those machines. The trend is widespread. The approaches are quite variable, as are the pace at which we're going to get to full automation. So when you start at the most basic, you have kind of like driver assist. So the person is still driving the machine, but there's some automation there to help him or her do his job better. And then you get to incrementally more robotics, which is generally, let's take the person out of the machine and let's give them a remote control. And that's a lot of the stuff that we sell, which is safety critical wireless controls. And then you go to task automation. So it's like, I need to do task X. I need to dig this hole in a certain way. Let's have the machine do just that task autonomously. And then you get to full autonomy, where it's like, well, I want to press a button and have that excavator go, take care of that site. Soup to nuts. It's going to work most of the day by itself. And so there's a spectrum of automation that people are developing on, and really where their approach lies really comes down to, like, what does the task actually need? How technically hard is it? What can the customer absorb? What's the company's approach? How conservative are they? So there are a lot of factors that go into it, but it's broad. All companies have bought into it. It's going to be across all machines, but there's this variable approach that really is case by case. So that's kind of what we're seeing. We're encouraged about kind of the broad buy-in, and we're seeing it from a variety of players. So it's not just the OEMs anymore. It's the OEMs, but it's also the specialized machine control providers like Trimble, Topcon, Leica, and the like. And it's also starting to be startups. So construction tech is something that's gotten a lot of investment in the past couple of years. A lot of the dollars have gone into companies like Procore that have been really into business management of construction sites. But we're starting to get into actually machine actuation automation. People like Safe AI or FORT Robotics getting a lot of funding these days. So the automated solution of the future is not necessarily going to be delivered by the companies that have owned the machines on the work site in the past. And so, we think that the tent growing bigger is a really good thing. Mm-hmm. I would say what we're also seeing is that there's kind of there's a walled garden approach. People aren't necessarily playing well with each other. So, the OEM A that has like 30 different types of machines is really concerned about making those machines work together, and not so much concerned with making them work with OEM B's machines. And that's the way it is today. And we think we'll get beyond that. The world will get beyond that, but that's the way it is. A bunch of walled gardens, which I think is kind of a phase that we'll have to go through. I would probably be remiss in talking about automation in this industry if I didn't talk about COVID. So obviously, if we can't get on construction sites, if people can't actually get to the job, then who's going to do the work? I mean, machines, automated machines, don't get COVID. So much like we see in many sectors of robotics and many sectors of the tech economy, the pandemic is certainly an accelerant for this trend of automation. So that's kind of like the broad picture as we see it.
Okay. Well, maybe could you go into a little bit about what FORT Robotics does? Do you guys work directly with an OEM, or kind of how do you guys play into all of this?
Yeah, so we have about 175 customers. About 50, north of 50 of those are very large companies. So we have a who's who of clients across this world. Our main verticals are construction, agriculture, manufacturing, warehousing, mining, turf care, airports, you name it. We're dedicated to enabling the trend of automation in the physical world. And so because automation in the physical world is really such a broad trend, we have a really broad cross-section of clients. Mostly today, we are working with OEMs on their products. We have a presence with end users as well, the companies that are employing the smart machines. But mainly we work with OEMs on making their machines safe and secure as they go through this journey. Mm-hmm. So the kind of challenges that we see with this trend with OEMs is there's just enormous complexity to begin with in doing a task in an automated way, whether you're picking a strawberry or spraying a crop or digging a hole or picking an apple or whatever it is. There's huge complexity. And you, as a robotics company or as a robotics endeavor inside of a machine company, you have to become expert at a lot of different technology areas, and you have to incorporate, the actuation and the sensing and the computing and the connectivity, and you have to understand the task from the machine's perspective. And it's like, it's really, really hard. It's hard. This world is very exciting, but the level of complexity is very high. The cost is very high. The development times are long. And so just on its own, like, these companies are biting off an enormous piece of the apple. And so what we're trying to do is take off the rest of the challenges that are not task specific, which for us mainly revolve around safety and security. And so there's a lot of attention paid to, like, how are we going to pick the apple? How are we going to dig the hole? And there's enough mind share dedicated to just the task that, the hidden gremlin in all of this is there's a lot of risk. There's a lot of risk in this trend. So machines that are connected to the internet, they have to be connected to the internet. They have to access databases in the cloud. They have to work with other companies in the cloud. They're connected machines. And with connectivity comes security risks. So, you have the ability for a bad actor, whoever they are, to get onto a machine and cause trouble. And that trouble could be theft of IP, it could be theft of data, it could be changing configurations, it could be much worse, actually. It could actually be bad actor does a security breach and causes people to die. So these things are big enough to kill people, and yet they're vulnerable. So security has to really be handled. Similarly, safety has to be handled. Like, we don't have a person in the driver's seat anymore. It used to be, up to the human brain to decide, like, is this a safe situation? Is it not a safe situation? Am I going to drive over somebody? Am I going to hit somebody with the bucket of this excavator or whatever? And now you take the human out of the driver's chair. Well, then how are we going to handle safety? Well, we're going to handle it through the tech stack that we put on these things. But the autonomy, the current state of autonomy, is doing its best just to figure out the task, the picking the apple, the digging the hole, right? And so, like, fully taking into account the inherent unpredictability of the real world, the physical world is a mess. It is a chaotic mess. So requiring the software to fully understand the world in a way that's safe for the humans and property around it, and figure out how to pick the apple, dig the hole, whatever, is just an enormous task. So whether it's the safety, which is a huge problem, and then the security, which is also a huge problem, there's like a lot for these machine developers to deal with that's not their core. Their core is picking the apple, digging the hole. So that's what we're trying to take off of their plate, is handle the safety and security for them. And if they can just rely on a trusted third party to do that, then they can develop much faster. Then they can focus on the things that really make their solution sing in the hearts of their customers. And so that's the role that we see. And we have an approach to that we believe, we strongly believe, we know is distinct and tailored to this class of machine.
Okay. So then, can you maybe talk about how you guys maybe help to overcome some of these challenges with, like, say, the security, or helping them develop the systems? Can you maybe delve into that a little bit more?
Sure, yeah. So how do we deal with safety? How do we deal with security? So on the safety piece, we firmly believe that humans have to be in control all the time, even if they're not sitting in the driver's seat. And so what enables that to be possible is safety critical wireless. There are a lot of ways to have wireless out there. We're not reinventing wireless. There's Wi-Fi, there's Bluetooth, there's LTE, there's ISM band radios, there's whatever. There's a lot of options out there. None of them are safety critical. And what you need is a safety critical link between the humans that are overseeing a machine and the machine itself. So that's one leg of our platform is safety critical wireless controls. And so you see, like on our website, you see our safe remote control, which looks like a video game controller, but is industrialized and safety critical and works to control a big machine. And so those are kind of like the physical manifestations of our technology, but really what we do is safety critical wireless. And so we get into programs with OEMs with regard to that, where it's like, well, I want to remotely control the machine, and your off-the-shelf product works. Fine, that's great. Otherwise, we can get into a development program where we sit down, we figure out what are your safety communication needs. It could be machine to machine, it could be multiple machines, it could be multiple people talking to multiple machines, it could be local, it could be completely disconnected. We're network agnostic, we're geographically agnostic. We just care about getting the safety critical message from point A to point B, from human to the machine it needs to control, or from machine 1 to machine 2. And so there are kind of two options for working with us with that. There's the stock products, or there's the kind of customized solution perspective. But then there's the second leg of the safety platform is, I mentioned how complex it is for a software-driven machine to figure out how to pick the apple, dig the hole, and be safe around people. So we're trying to take away part of that complexity by telling machines what they're allowed to do. So regardless of what the AI tells it to do, we need to be the governance backstop for these machines that tells them, oh no, you can't do that. That's an unsafe movement. Regardless of what your application told you to do. So that's the second leg of safety. And then there's a whole suite of security. We have a core approach to security that lets us address a lot of different threats. So we have a hardware-based security module we put on machines. We have a security certificate authority that we own that's in the cloud. And with these two pieces, we can have the cloud certificate authority authenticate to the on-machine security module. And we can use that to authorize a variety of different things. So that could be local physical security. So a lot of these machines have the same keys. So we can put basically a digital key on these machines, so that whoever is trying to get on the machine is the right person, is the right permissioned authorized person, and that's local physical. Similarly, we can use the same technology to authorize remote access, so that before anybody can wire into a machine to do whatever they need to do, they have to authenticate with our system, and that keeps the bad actors away. Similarly, any kind of change, whether it's a software update or a configuration change, can be authorized with our security platform. Similarly, if you have a bunch of machines that need to work together, we can make sure that only the authorized ones are able to talk to each other, rather than all machines able to talk to every other machine. We can basically segment networks that way, which provides a lot of security. Security in the event that there's a breach, it can't go further than the authorized path. So the point of all this is there's a tailored approach to address the unique challenges that are coming up now because of this new world that we're in. I mean, we didn't invent machine safety. We didn't invent cybersecurity. We didn't invent physical security. But we do have a unique understanding of what these machines need with regards to safety and security, and we've tailored our technologies to suit that type of machine.
Okay. All right. Well, then I guess just the last question I had was sort of how do you guys foresee automation continuing to progress in the coming years?
Well, in a really exciting way. We're excited. We think that the benefits to humanity, it's ironic because we're talking so much about like these automated machines, and the fixation is so much on the technology, but the technology is out there for humanity. Mm-hmm. Like if we can increase safety, if we can increase productivity, fewer people get hurt, people make more money, there are more jobs that are out there. And so automation can be seen and should be seen, in our opinion, as not only a cool technology that's going to solve some problems that we have right now, but actually a huge enabler to a better way of life down the road. So, that's like the macro picture that we see. But like at the technology area, on the technology level, you hear of like level 1 through 5 for self-driving cars. There's a similar allegory for off-highway vehicles, and I mentioned it earlier, going from driver assist to remote control to task-based automation to full automation, and every machine from every OEM, whether they know it or not, is on that progression, somewhere on that progression, and some will get to the end sooner than others will get to the end, but eventually they're all going to get to the end. So then I'd say, what's after that, right? So what comes after that is fully autonomous machines working together. So you have an excavator that works with the truck. Okay, different form factor machines, both automated, working together. So that's what happens next. But right now, the world is under this kind of walled garden format, with this walled garden perspective, where really what's feasible is the one manufacturer makes the excavator, one manufacturer makes the truck, and really controls the integration within the two. The phase after this multi-machine collaboration is multi-OEM collaboration. So they might not know it now, but eventually, all these OEMs machines are going to work together. And then the phase after that is a world where you have not only multiple machines from multiple OEMs working together, but you have applications from a lot of different people working on all those machines. So imagine a Caterpillar machine working with an application from a startup, collaborating with a machine from Deere, who also has an application from another third party. You got 4 companies in there all working together on an automated work site. This is not a world today that many people are really thinking is going to happen, but we believe it's going to happen. And so the question then becomes, how are you going to maintain safety and security in that kind of world? We have all these different companies working together, and the consequence of doing it wrong is people die. So not only do we need to make sure that we have a good approach to picking the apple, digging the hole, but we also need to ensure that across the entire ecosystem, their safety and security ensured. Obviously, that's why we exist. And then after we get to this fully disaggregated multi-machine collaborative world with no walled gardens, you'll start to see a lot of different form factors. So does a tractor of tomorrow look like a tractor of today? Probably not. Does the truck of tomorrow look like a truck of today? Probably not. Does it even roll? Does it hover? I don't know. I mean, like the whole world will be different a few years down the line, but the need for safety and security and working around humans, it will persist. So that's why we're here. A machine platform as really a baseline of applications looks a lot more like the IT world that we have, right? Your computer has a bunch of applications. Your phone has a bunch of applications. And it is the companies that have embraced that openness that have survived. So, BlackBerry, we don't really use their phones anymore. Windows Phone, who has one of those? Everybody has an iPhone. Everybody has an Android, because these are open platforms that have diverse ecosystems that provide a lot of value when you get the ecosystem in your pocket. I think it's kind of hard to imagine today, but I think the off-highway world of the future is similar. You're going to have a lot of platforms and a lot of applications, and there's going to be heterogeneous mixing between those platforms and between the applications. And so I think it's going to be really interesting to see how the OEMs approach this question of openness. So you know, we're out there to help regardless of any company's approach, because safety and security are so universal. But that is the world that we see in the future.
Okay. Well, great. Well, thank you again. I really appreciate it.
Yeah,
A lot of good
our pleasure.
information.
Thank you.